in this video, I am going to show you how to use the bisect module on Python, and it's basically a way to use the binary search algorithm to locate items in a list. And you could also use it to insert items into a list, as long as your list is sorted. So if your list isn't sorted, just use the sorted built-in. So I'll make a very big list. I'll make my list is assigned to list range. It's going to start at 1. It's going to go till 10 to the power of 10, and it's going to have a step of 10. Now it's going to take a while for this list to start up because this is a very big list, but the reason I made it like this is to show that I could have done it from 1 to 10 to the power of 9, but maybe you think that bisect just returns whatever number you pass to it. So I'm just going to show you that it's a lot better than that, and you can see how this list takes super long to load up. And if I want to locate where a certain number is in this list, it will take a while. I mean, maybe it won't take very long, maybe it won't take a minute, but it could take a while. So let's say I have the number 987654321. Want to find where the index of that is. Now that's going to take a while because this is a big list, and the way list indexing works is that it makes a full scan of the list. Okay, that didn't take too long. That took like a few seconds. But imagine if that list was much bigger and contained a much larger amount of numbers. It doesn't just have to contain numbers, it contains strings too, or other objects. I mean, if it's containing numbers or strings, you should be using arrays, which I showed in another video. But if it's some other type of object, you might not be able to store them in an array, and a list scanning can take a very long time if the list is very big. So now I'm going to show you how to do this thing with the bisect module. So we're going to import bisect, and bisect has 6 functions in it. It has bisect, bisect left, bisect right, insort, insort left, and insort right. Now bisect.bisect is actually an alias for bisect.bisect right. Here, I'll show you. Is bisect.bisect right. It's the same thing. And it's the same thing for insort. Okay, so the way bisect.bisect right and bisect.bisect left works is that bisect.bisect right, it's the same thing. It will locate it the same way. The only difference is that when it finds something that already exists in the list, will it go to the index after, on the right, or on the left? So we can see that you can locate the index like this properly using, the only way to really do it is using bisect left. But first I'll show you how to do it with bisect right. So you can either say bisect.bisect or bisect.bisect right. I'm just going to use bisect.bisect to make it more concise. And you're first going to pass in the list, and then what you're trying to locate. And be sure that this list is sorted. So if it's not sorted, you can use the sorted built-in, like this, sorted my list, like that. It may take a while though. Or you could sort it in place also by using the .sort method, like that. Okay, but anyway, you put the number here, and there's a few other parameters I'll get into later, but it's almost instant. Now, this didn't give us the number we were looking at before. This is a 3, but it should be 2, because it locates that this is in fact a number in this list, and it goes to the right of that, and now we're at this index. If we want to get the exact index that it's actually at, we're going to have to use bisect.bisect left, also almost instant. So if this list was much bigger, it doesn't change because that's how the binary search algorithm works, as long as your list is sorted. If your list isn't sorted, I'm pretty sure it'll just give you a 0 because it can't use the binary search algorithm on a list that's not sorted, because that's how the algorithm works. Now, there are other parameters that you can add as well. So there's the low parameter, the high parameter, and the key. So low and high just give you like boundaries of what you should be searching. So if you know for a fact that something is between two other numbers, you might want to provide those numbers to give it maybe a little bit of a speed up. So we know it's more than 1,000, and we know that it's less than, let's say, 100 million. Yeah. So it might make it a little faster if you have a big list. Actually, I don't think that's how that works. But whatever, you can provide low and high things anyway if you feel like it. It will. I don't think it will actually make it faster, but whatever. And then there's also the keyword argument. You can make it search things with a certain key. If you're aware that there's the keyword argument in sorted and max and min, it's the same thing. So I don't think I really have to explain that, and it's not useful in this context anyway. And if you really want to like badly know what key is, but if you actually have use for key, then you could look it up. It's on the docs, Python docs. It's not complicated. Okay. Now, what if you want to insert a number into a list? So you can use the bisect.insert, or insert left or insert right, and you can insert with the same parameters as the low, high, and key parameters, and you just give it the list and you give it a number to insert to. So let's give it 987.654.320. And this one, I don't know why it's actually taking a bit of time for some reason, but I'm assuming that's because the way it works is essentially it uses the binary search algorithm first with bisect.bisect left, and then after it does that, it inserts it into the list. And because we have a big list, it takes a long time to insert, because the .insert method is not like a binary search something. So this might take a bit of time. Yeah. And now you can, I would check if 987.654.320 is in this, but it will take a really long time, so I'm not going to do that in this video. So that's it for bisect. And if you like this video, then that's really cool. And I'll see you in the next one.